Welcome. Today we would like to talk about a useful open access feature, the transform. For some, this may seem rudimentary. However, we've noticed the fundamental concepts get a lot of clicks on our training site. So let's get started. What can we do with oaTransform? How can I use the transform within my application? I can change the orientation or location of a shape. I can replicate shapes. It works with an array of shapes and lets you set site references for placement. You can use oaTransform to get relative coordinates within a hierarchy. Several other classes accept the transform as their argument, so we should get familiar with their use. oaTransform can change the orientation of the shape using the enumerated list of arguments. Some of the arguments seem redundant, as mirroring about the axis is supported. I made a shape of the letter F, as its orientation is obvious. If I mirror about the x-axis and rotate 90 degrees left, we have the shape shown on the screen. Note the rotation is about the origin of the shape. If you use the transform to only move a shape, the oaTransform needs a block reference. We can combine, rotate, and move in the same transform. We can concatenate transforms. Concatenating our move and our rotate has the same result as two calls with separate arguments. The invert method provides an undo or a go back function to revert a complex transform back to the original state. If we've already used a transform, we can apply the inverse transform and get back to the original state or location. Using copy, we can easily replicate shapes within a loop. Arrays of shapes are easy to produce with the transform. If we concatenate transforms, we can get the location of a shape relative to another block. Otherwise, your shapes all are relative to the master block where the shape exists. This has application for tools that need to work in a flat environment. Let's look at an example. I've created a design using a single inverter from our library, but I built it into an oscillator with a hierarchy. The inverter used is combined with another one and made into a buffer. We'll examine the buffer here. And note the two instances of the same inverter inside the buffer. There are also two fill cells inside the buffer to give it a little more room. And if we go and select one of the inverters and actually descend into that design, you'll note when I select the polygate and look at that shape, its information shows a bounding box that's at 0.095, 0.195 in the X. Now, if I go back to the buffer level and select it, I get the same coordinates. So the coordinates at the buffer level of these shapes are actually relative to the library book, not to the instance. This is where transform can really help us. Now we will take the buffer and include 3 of those with another inverter and create a delay line with an odd number of inversions. Notice we have 3 instances of the buffer and 1 instance of an inverter. Now, if we choose a poly gate from the any of the buffers or the inverter and look at its information, we see that its coordinates are the same coordinates we saw previously. Now let's take 3 of these delay lines and make what I've named long line, which is nothing more than 3 instances of the inverting delay line. And note we're at the 4th level of hierarchy here. If we select a poly gate from one of the inverters and look at its information, even at the 4th level of hierarchy, we still see the same coordinates. And finally, we take 3 of the long lines and a few interconnects and make a inverting oscillator. And if you'll notice, there are 3 instances of the long line. This being the 5th level of hierarchy, we can still see the same coordinates if we drill down and look at a single inverter. And here we have the gate of the inverter, and there we are, same coordinates. So let's take a look at a Python script that will create a copy of this design, but a flat copy. So this begins with the usual boilerplate code, which is open the library, open the cell view, and open the text file. But something you'll notice here that's a little bit different is we're creating a new design. In addition, the new design will have the name of the previous cell, and we'll append _flat to that name and create this new design. Next, we will define a function called flatten instance. And what this function will do, get the top block for the design that's passed in. It will get an array of all of the shapes in that instance. And then for each shape, it will make a copy in the new design with the coordinates changed according to the transform that was passed in. Then we will take the array of instances and go through them individually, and as we descend into each instance, we'll get its transform, and we will concatenate its transform with the current transform, which will get us the coordinates relative to the level, the hierarchy level we came from. And then we will get the master of that instance, and then we will recursively call this function using the master of that instance and the new transform that we got when we descended into that instance. And that will in turn copy all the shapes again and descend into any other instances that are remaining in that tree. And to initiate the functional code in this is actually 2 lines. We get the current transform and we call the flatten instance function. So given that, let's run it and see what it does. Okay, let's open our flattened copy of this design and see what we see. The design at the top level looks the same, though if we look for instances, the instance report has nothing in it, meaning there are no instances here. But now if we select the gate of one of the inverters and look at its information, it has actual coordinates relative to this level. And note that those are different from the coordinates for another shape. So it has taken all the shapes in this hierarchy and flattened them to a single level. That can be really useful when you're working on an application that does something like metal spacing checks, and you need to get everything in one layer to examine it. You can do this in memory, or you can do it by copying to a separate design. So, but the fundamentals are the same, and it doesn't take a lot of code to do it. A transform is a really efficient way of dealing with hierarchy. And I hope that provides you with another tool for your toolkit. And thank you very much for attending. We'll now take questions and answers.